Ready, Josh? Yeah? Okay. You guys all got this. Mutations. Not the X-Men kind. So I wrote down here, is this realistic? Well, no. Special weird superhero powers and things. No. What is realistic is this. Here is a black bear. No, Mr. Dewick, it looks white. No, it's a black bear family, but it has a genetic mutation. Its fur is kind of an off-white color. Put your pencil down and look up. So let's talk about mutations. Hannah, could you read that sentence there?
A man ran for the bus and did not get his dog.
It's a bit of a nonsense sentence, but what I did is I made sure it's made up of 3-letter words. And the reason I did that is your DNA comes in 3-letter chunks. Now there are 4 base pairs, A, G, C, and T, but your proteins are read 3 of those codes at a time. So here is a sentence. The man ran for the bus and did not get his dog. Okay? Bases are read in groups of 3. So as long as the words make sense, your DNA code that the ribosomes and that whole procedure looks at will make Mason the correct protein. Can you read that for me, Hannah?
T-man ran for the bus and did not get his dog.
You can still read it-ish. Will this protein be okay? Well, maybe. Maybe. Most of the sentence is still okay, Matt. Maybe. How many words, how many groups of 3 are incorrect? Only 1. If that was your DNA code, we would say minor mutation. In fact, probably your body would be able to ignore it and go happily along. Can you see what happened here? How is this sentence different? Yeah. Yeah. Well, we lost 1 base pair in our DNA, and because the cell system still reads in groups of 3, it's still putting them in groups of 3. Now, instead of only 1 base pair in the wrong place and everything else correct, losing a base pair means everything after the loss is now in the wrong order. And that's a problem. That's a problem. Okay? So how many 3-letter words are garbled here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Kevin, you okay? You with me? You awake? Good. These are the types of mutations, and I think now is where we're starting with the notes. What is a mutation? It's a change in the order of the DNA code of a gene. A mutation is a change in the order of the DNA code of a gene. That might be a good one to write down. Mason. You with me now? Weekend's over. Okay? That's all it is. So whatever ignore what they're talking about on the movies, but when we say you've had a genetic mutation, what we mean is some chunk of DNA code, the order has changed. And there's 3 main ways, Cole, this can happen. Types of mutations. There are 3 types of mutations. They are deletion. You all know what the word delete means. Deletion, Ibrahim, is when you lose a piece of DNA, a base pair, a letter. Addition That's when you add a letter and substitution. Substitution. That's when one letter gets swapped for another letter. You want a good example of substitution? This one. We swapped an H for an E, but everything else was okay. Here is an example of a deletion. You can also imagine an addition. Maybe if I put a Q right there, then all the letters would get bumped over in the wrong way as well. Well, not on this one because I've already got a deletion, but if I go back to the original one, if you had an addition right there, then the E would be part of the second word, everything else would get bumped up. What that really means, Matt, is the two most harmful, the ones that have the biggest effects are deletion and addition. Maddie, it's a big deal if you add or lose a base pair. It's not that big a deal if one letter gets transposed because maybe the rest of the protein might in fact, it might even still work perfectly fine, or it might only be a minor change, but yeah, it'll work. Okay. Generally, mutations have no effect. Give me 1 second. So generally, mutations have no effect, but they can also be harmful. We call these negative or beneficial, helpful. What do you think we call those? Cole? Are you positive? Oh, okay. Let's talk about some examples of both in just a second. I wrote here, complete the mutations practice section in your notes. You'll hand it in at the end of the lesson. We're going to do it together here right now. Let me go like this. Let me find your notes, Mr. Dewick. So here is the mutations practice. Let me make this a bit bigger. So the original sentence, the boy cut his lip and ate the hot dog. Again, it's not really a sentence that makes good sense, Nick. I'm looking for 3-letter words because DNA is read in groups of 3. Part 1 says, create a substitution mutation. A substitution mutation, Nick, might be replacing, one letter. Let's replace the letter H with N for Nick. Okay? We would get this. Tn. Boy works fine. Cut works fine. Niz. Lip works fine. And ate. Tn. Not dog. Now that would be if we substituted the same letter in a big long chain. That doesn't happen very a lot of the time. All that happens is only one single letter gets changed. Okay? Is this likely to have a major effect? Probably not. There are some words that are wrong, but most of them are fine. Then it says mutation. So you know what? How about we'll start with the boy cut his lip and ate the hot dog, and let's put something between the B and the O. So I'm going to go like this. The bro. I'll put an R between, and then I'll have YCU THI SLIPAN DAT ETH EHO TDO. There's an example of an insertion or an addition mutation. All I did, Ibrahim, is add one letter, but you can see everything is out of place now. Do you think this would have a fairly major effect? Yeah. Okay. So here might be a nice couple of test questions. I'll give you a set of DNA, ACT, GCC, ATT, CG, and then it says circle the mutation that was made on each of the sequences below. So here's a mutation. Whereabouts does the mutation occur? Do you see it? What letter number does it occur at? Letter 1, letter 2, letter 4, right there? Oh, in the original it was a GCC, now I have a CCC. What kind of a mutation is that? Addition, deletion, substitution. Is that okay, Katie? Yeah? What letter number is the mutation here? Do you see it? Over here, yeah? We lost a T. Right about there. Will that have a big effect? Yeah. Well, Mr. Duke, it's at the end. Yeah, but proteins don't work that way. It's not like, oh, it's at the end, it's not, most of the sentence is okay. You're going to have a bunch of stuff out of place. Here, ACT, GCC, right there. This is an insertion or an addition. So this is what we call a substitution. This is a deletion. That's an addition, mutation. Okay. Which one will have the least effect? That one. Which one will have the greatest effect? Probably that one, but I'm not. Yeah, we need more information. Is that okay, Cole? Let's talk about how all this works and some of the consequences then. Oh, and you guys can turn the page. Some examples. Millions of people on the planet are infected with HIV. And so they are at risk to develop AIDS. HIV is a virus, and it can lead to AIDS. However, a very, very, very few individuals have a very, very rare mutation that makes them resistant to HIV. Is this a positive or a negative mutation? Okay. I believe there's a gentleman in Germany, and I think his body has actually cured itself, beaten off the same way you get better from a cold. His body has gotten better from HIV, and so they're studying what his blood is able to do and seeing if they can use that as a cure or a vaccine or a treatment. Very rare. Very rare. Here's one that's a little more common as well. So substituting base A for base T in one particular human gene results in the protein, and here's the name of it, hemoglobin, taking on a different shape. Results in the protein hemoglobin, spelled the way it sounds. Hemo, H-E-M-O, globe, G-L-O-B-I-N. What is hemoglobin? Anybody know? You all have lots of it. It's very important for you. Okay, it's the protein that's part of your red blood cells. In fact, it's the protein that helps carry, when you breathe in, it's the protein that helps carry the oxygen out of your lungs and into the rest of your body to the various cell processes. So when you have this swap, the molecule, the protein doesn't quite shape correct. So this abnormally shaped molecule can't carry O2, oxygen, as efficiently. And it can also block blood flow. It doesn't go through the small blood veins, the really, really small ones, as easily as normally shaped hemoglobin does, which can lead to organ damage. We call this sickle cell anemia.
Thank you.
Sickle cell anemia. Is this one a positive or a negative mutation? Very negative. Very negative. I have some pictures here. So on the right, this is what a normal hemoglobin blood cell looks like. You can kind of see why they call it sickle cell anemia. This is when you have that swapping of the base pairs. A sickle is like a half-shaped circle that you use to cut down grass. It looks like a half-shaped circle. So people who carry the sickle cell gene have red blood cells that are letter C-shaped. Normal red blood cells are disc-shaped, and these can carry more oxygen. Other examples of negative mutations, cystic fibrosis is another example of one. So we have positive, we have negative, then we have some that are neither, neutral mutations. As an example, we have the Kermode, I don't know whether it's pronounced Kermode or Commode. I think it's Kermode, but I'm not sure. Spirit bear from the northwest coast of BC. This is a species of black bear that has developed a mutation so that some of the bears, even though they're black bears, the gene that makes their fur black is not passed on, and their fur is kind of an off-white color. Why is it neutral? It neither increases nor decreases its survival rate. It just is. I knew I had a video here. Put your pencils down. Mutagens. This is a word that you probably will see on your test. This is something that causes mutations to occur in the DNA. This is something that causes mutations to occur in the DNA. Let me just pause for 1 second here. So what are things that can cause mutations? Some viruses. UV rays from the sun can cause skin cancer. That's a mutation. That's why we say wear sunscreen. Cigarette smoke. You might want to write those down. That would make a nice question, I think, on a test, a written question. Name some mutagens. Did I have this in your notes, that assignment there as well? I do? Okay.